today's mission is to at least cover some of the basics of SQL. I'll be talking through around like starting from what a database is and like how we can overly generalize the kind of databases, and we'll dive deeper into some of the queries, and our goal will be to cover as much as we can during this time. So first of all, what is a database? So database is any collection of related information. So it could, it is a very general term that we can, start off with by understanding what a database is. It could be just a phone book wherein you record your contacts with some more information relating to your contacts, like address, phone number, likewise. Now it could be a shopping list. It could be a to-do list. So all of this is, a way of organizing information and keeping it in one place such that you can always refer to it. So that is the concept behind having a database. So, database currently we use a lot of databases. They might be hosted on cloud. There are various cloud platforms which are available, which is Azure, GCP, AWS. They all provide kind of, similar kind of frameworks where you can host your databases on the cloud, and also you have some local versions. So if there might be some transactional database which company prefers to keep on premise, so there is an availability of keeping those servers locally if if your business requires that, or you can host it on cloud itself. So nowadays we have those kind of databases, but there should be a way to communicate with the database. So if we are using something to store data within, there should also be a way to query that data, to fetch that data such that we can utilize it for our processing or for our purposes. So that is why we have something called as structured query language. So using SQL or structured query language, we communicate with the database. Now, how do we communicate, and how, well, first of all, let's say we have a database, but there could be multiple database just because we want to store related information in, or it is just a way to organize things or to logically separate some of the things adhering to the GDPR guidelines, or it just might be some company policy wherein we have multiple databases to store different set of information. So there should be a management system which we call as a database management system. It is a special software program um, that helps users create and maintain a database. It makes it easy to manage large amount of information and handle security, backups, importing, exporting data, concurrency, interacts with software applications, and whatnot. Now, with the course that we offer, we do have Microsoft Workbench that we use. It is again a management system. It is like a tool that we use to query our databases or MySQL databases. But in this presentation, I'll be using something called as MySQL Server Management Studio. So with that, I can also use that to connect to other data sources, like for example, a database hosted on Azure. I can directly connect it to it via the Server Management Studio. So they all use structured query language. However, there are minute differences in the syntaxes. So in some, I mean, you might have heard a lot about Postgres, or and there are different kind of databases available. Like even with SQL Server and normal SQL, the way in which you write your query changes a bit. So the syntax changes quite slightly, but overall the general idea behind writing a query and the rules behind writing the query is it's still the same. So now if we were to divide the kind of databases, we can divide it into two parts. So one could be online analytical processing, or what we call as OLAP, and another part could be online transaction processing. Now this is a snippet that I took from AWS website. Now here we'll be looking at some of the industry level architectures of how now this is just an example which is available on AWS, but we'll understand how different things in this architecture works together, like an overall view, so that you guys can have an idea as to what OLAP is, what OLTP is, and why are they, first of all. So as the name itself suggests, one is used for analytic purposes. So it is more to do with reading data than to writing data, because with analytics, you need to fetch data. So that is, so that it is more powerful when we were to when there is no write operations, but there are more read operations, if that makes sense. But with transaction processing, we use that to store our data, to manage, to create data or to update data. So that is where we will use those kind of databases. Now, if you look at this diagram, here we have OLTP database. So this is in a corporate data center. So this is a database which is available in the company's data center itself. Now they want to use AWS cloud to do analysis on their collected data, right? So how do they do that? First of all, you would need to make a JDBC connection to the cloud, and so basically this little icon that you see over here, AWS Glue Data Brew, is just responsible for connecting with the OLTP, doing some sort of a transformation, and then storing it into this data storage that we have in AWS. Now I'm not going much deeper into it, just to give you a bird eye view of how things happen. Then once the data is stored somewhere, it is then crawled. So when you crawl the data, you do not need to, provide a schema for it, because glue crawler does it automatically. So it creates those tables. Now those tables are available in glue data catalog. That table will be used we can use those table to query in AWS itself. So here we will be using Amazon Athena. Here we'll be writing our SQL queries to analyze our data. The data that was connected where in OLTP database, where in that corporate data center. So from there to making a connection to storing it in S3, and then crawling back, creating a table, then analyzing it via Amazon Athena. And to visualize the data, we can use QuickSight, which is similar to like Power BI, but again it is an AWS product. Then with the same data, we can host our machine learning models on AWS SageMaker and SageMaker model. So now if you have multiple such databases, different kind of databases, so you aggregate everything into a data warehouse, which you call as there every data sources will be aggregated and it will be available at the same place. So when you write a query, it won't be like you're fetching it from different sources. It is all available in the same place. So those kind of databases like AWS Redshift, for example, that is a type of data warehouse. Again, what we call it as OLAP, used for analytics purposes. But what kind of databases you use to create or to store certain information, so those actions are called as transactions. It is more to do with writing, not reading the data. So that is OLTP databases. When you are talking about analyzing the data, you need more efficiency in terms of fetching the data as quickly. So let's say if you have petabytes of data and you need to run a query, then of course you would need to if you think about running a query one by one like in a brute force way, it's very computationally heavy. So you need more read replicas such that a same query is executed in different clusters. So that is the concept behind having a OLAP database. So it is more it has more read replicas to support more read functions. But yeah, overall this is what kind of databases we have: OLAP and OLTP. Now we were talking about a lot about fetching the data, and how we do that is via a structured query language which we call as SQL. Now SQL itself is divided into the whole the commands that we use in SQL could be divided into these type of categories. So I'll just speak it out first, and then we'll look at the kind of commands that are available, and it quite makes sense as the name itself suggests. So the first one is DDL, which you call as data definition language. So in data definition language, what you do is you create a table. So think of it as creating a template or like an Excel file, which will be used to populate data. So first, when you want to create an Excel file, what do? You define columns, and then in that columns, you just put in data. And then you might need to drop a column. You might need to alter a table. So all those kind of operations which relates to where the template the template using which I'll store the data, or what we call as a table. So all of those commands relates to data definition language. So it includes these kind of commands: create, drop, alter, truncate. Then we have data control language. Now, data control language, name itself suggests it is used for control, giving access. So how do we give access? We grant access or we revoke access. These type of commands are in DCL. Then data manipulation. So once I have a schema made, once I have a structure made, then I would want to insert data into it. Sometimes I want to update the data that I already have. And sometimes I want to delete the data within. So for that, I have insert, update, delete. So these kind of commands. Then we have transaction control language. So these type of commands are more to do with sometimes, let's say you have a lot of tables. With that table, you can create a table that you want, which may be a combination of combining multiple tables and then manipulating some of the data within those table and creating a table as an output that we want. So that might be a series of SQL operations that we will write, right? And sometimes when doing that operations, I make a mistake. So what if I want to go back to the previous step? So for that, we want to control the kind of transactions we are doing. So that comes under transaction control language. So here we commit our transaction, and because we are able to roll back to the previous step if we make a mistake, and then we can also save point. It is like a checkpoint. So from that we can continue. Now this is again on a more bird eye kind of a view. Now again, when we say this was all about creating data, right? Now we also want to query, we want to fetch it. So that is data query language, this part, and that has select operation. Now we can say the operation in database using DPMS are to create, read, update, or delete, or we say it as CRUD operations. Now, let's say if we have a table made, table is you can understand it like a CSV file with a sheet, okay, which has tables, and there are different values that you can put inside each column. So now each column, let's say if you are making a student attendance kind of an Excel file, okay, so it would have student name, then it would have maybe student roll number, so that would all be numerical form. Then it might have like student absentees or presentees. You might want to extend that data to hold certain student information like the student grades or some sort of information. Now, if you think about it, the different information that I want to store regarding a student are of different data type, like roll number is an integer or numerical data type. So for that purpose, we have different data types that are supported by SQL. So one is integer. So here integer data type can be used to store whole numbers or integer values like 1, 2, 3, -1, -2, those kind of things. Then decimal is a data type which will allow you to store decimal values. Now, why do we need to define the data type? Because on the back end, it should understand how much space is required to store a certain data. Now, when if while working with computers, we are thinking as granular as possible and as general as possible. So there are two aspects of it. So if we are introducing data types, we also have a memory allocation thing to think about. So that's why each of the data type would have a different set of memory which it would need to store. So for example, integer might not require that much memory to store data that decimal would, because decimal has to store the integer part and the decimal part both. So if you think about just few rows, it does not matter a lot. But if we are thinking about billions and millions of rows, then it does matter a lot. Then student name could be of text data type, so that could come under varchar. Then we have blob, which is binary, true, false. Then we sometimes want to store date, that is of date data type. And then we have timestamp, which is just date with timestamps like minute, hour, seconds, likewise. Now, what we'll do is, my goal is to cover a lot of queries. So what I will do is I'll just jump to SQL Server Management so that we can cover some queries, and also I've been having some network issues. So since I'm sharing the screen to write the queries, I'll just stop my video so I save some bandwidth. But I'll toggle on and off when I speak. Right. Okay. Let me take you through the platform first. So this is the Server Management Studio. I have connected to essentially AdventureWorks database, which is a sample database that is provided by Microsoft. Happy to share link across after this. But it is a sample database that you can use to directly work on your queries, and then you can just use it for practicing SQL essentially. But before starting, I want to cover some parts around how the commands which we use to create database and want to update database and those kind of things. So first of all, on the left hand side, this is an object explorer. So basically all the databases are given over here. As you can see, this cylindrical kind of icon, with it tells me that I have one database, AdventureWorks. I can have one more, but for that I need to create one database. So let's create a student database first. So what I'll do is I'll write create database, and then I'll name it as student. Um, Now the idea is not to explain like how to write each and every query and the syntax of it. The idea is to like take you guys through how queries are like, what is the work of the query, and then we can dive deeper into syntax when the course starts. But I'll try my best to take you through how things work. So what I've done is I've created a database student, and as you can see, I get an output. So command completed successfully. I just refresh this and I have a database created. um should be right. I'll just try and execute it now. Let's try and use it. So if that works, that means, oh, I should have created school. My God. Right, okay. So I created student by mistake. Just delete it. Right, okay. So I have a database created using this command, create database. Now I want to use that database. So for that, I'll use another command, which is use, and then the database name. So because you have multiple database, you need to direct that which database you want to use for your command. So once I have used school, then all of the create table or whatever kind of a syntax that I'll write over here would relate to school database, and it wouldn't touch AdventureWorks at all. So that is after I've used this command. So now let me expand this, and then we have different kind of sections over here. So we have database diagrams, which is kept on this folder, but I'm interested in tables, which is where my table should be. Now, I do not have any tables over here. As just to compare, this is how tables would look like. But school database is currently empty because I just created it. So I would want to create a table first. So I'll just create a table and then I'll name it a student, because this is where I'll place student data. Okay. Now, uh, because I want to create a table, I'll use create table command. Then there'll be here, I will put the name of the table that I want to create. After that, I want to specify the columns that I want the table to have, its associated data type, and some extra attributes around that column, which we'll look at. And I'll explain that. But first, I want this table to have a student ID, and I know it is of integer data type, because student IDs, I know that all the students have a integer ID, not numerical in nature, but every student should have a unique ID. Okay, and every student, if he or she is a student, they should have ID. So a student ID column cannot have any null values. That means a student ID cannot have any empty values. It should have integer values. It cannot have any duplicate values. So if the criteria is to not have any duplicate values, if the criteria is to not have any what do you call it, null values, then that column we can name it as primary key. So the primary key column basically is unique and it does not have any null values. As simple as that. So now another column will be the name column, which will be of text kind of data. So that is represented by varchar, and here I'll just write the amount of characters or I'm allowing for this data type or for this column essentially. So I've written 100. So, and also every student should have a name. So I'll just write a constraint that it is not null. So if we do not pass in any name while creating an entry in this table, then it will give you an error. So that is what a constraint means. So but we'll look into the error and then we can understand the constraint when we get to it. So again, then I can do right. I'll just execute this. So command completed. Now I would want to insert data into the table. Now, because we just have like 15-20 minutes left, and I want to cover some more queries. What I'll do is I have some queries pre-written and I'll explain that to you. So once I have created a table, I can refresh this, and inside this table, I will have a student table. Now, if I want to input any values into the student table, then I have to use the insert into command. Now, insert into command wants to add value or insert any rows to which table? Student table. So that name should come over here. Now, all the values that you want to pass, you pass it as, closed inside what we call as, parenthesis in programming, but this is like round brackets within which you'll specify in first starting off with the student ID, which is 1. After that, the name of the student. After that, the major or the subject that the student is enrolled in. Now, so I have passed in required information. So this is like the one way in which you can, put insert data into the table. But here I haven't passed like which columns I want to put data in, because if I haven't passed, that means I have sufficient data to pass for every column. But if I only want to put student ID and name, and I do not want to put in the major of the student, maybe the student has just enrolled and he hasn't decided of a major yet, maybe he's in the first year where he does not have to currently. So in that case, what I will do is after this, I will write another round brackets, and I'll then mention the column names, which I want to input data of. So what will happen then is, let me execute this, and then let us look at the table finally. So for that, I will write select star from student. Right. So what has happened now is, I'll explain this syntax to you. However, this is used to look at the table. So this is a query language. So you've written a query, and you will get what is written inside the table. So here I am getting a student ID 1, Joe, and chemistry, which I have inserted once. After that, I inserted this data. So as you can see, there is a null value because I haven't inserted any major into it, right? So major column I haven't inserted. Now let's say if I want to store a GPA as well. So what I can do is I can add another column, but for that, because I'm handling or dealing with columns currently and not the internal data, so I'm dealing with the structure of this table. So for that, I'll use the alter command. So alter table, I want to alter one table. Then which table? I'll have to specify the student table. Then what do I want to do? I want to add what? I want to add this column GPA. And then what data type should it have? GPA should be of decimal data type. Now, when I execute this, the commands completed successfully. Then let's execute this. Because I'm sure it'll have null values, because of course we just added this column and we didn't add any more data into it. So what I can do is I can update these values. So what I can do is I can write update. Then what do I need to update? I want to update the table students. And then what do I want to do? I want to set the GPA value to something, but I should mention, right? Like, should I set this value or should I set this value? There should be something to decide, right? So then we'll use a where clause, like where name is Joe. So let me write that code, write that query, then we'll understand it. So I want to set GPA column to say 3.4. Yeah. And what do I want to do? I want to set it where name equals to Joe. Right. Now, let me look at this. So yeah, we now have a GPA 3.4, but this 0.4 is missing currently. It is because here we didn't specify that it can have 3 and then after decimal 2. No, actually this is numerical and this is, yeah, I would need to specify this. Otherwise, it'll just convert it into an integer, because I haven't specified how many decimals it can take and stuff like that. So yeah, that is how we would insert data into the tables. And this part is essentially you would use it to query the data. So here I am saying select the star basically means select all from student. So that means I want to select all the columns from the student table. So what it will do, it will give you all the columns from the student table. Now, if you want a particular row from this, or if you want to say, I want that column where the GPA is less than 4, so I can also do that. So where GPA is less than 4. So execute, then I get that particular column. So I purposefully wrote GPA in uppercase because I want to also explain that this isn't case sensitive. But a good practice would be to write it in how you have written the column names. Okay, so these are some of the commands around the data definition language or data manipulation language. Now, what we will do is we'll just look into some of the commands around analyzing some of the data in AdventureWorks database. So let me just remove this part. Now, what I want to do is I want to use, instead of the school data, school table, I want to use AdventureWorks. So instead of the school database, I want to use AdventureWorks database. So if you remember, I used this command to get to the school database, but this time I want to change it to AdventureWorks. So I'll have to write adventure, but yeah, it gives me an option to select. I can press tab and I just don't need to write the entire name then. So I execute, commands completed successfully. Now I can start, querying this data. So let's see what kind of tables does it have. So it has something called as sales LT address. So the sales LT seems to be a common thingy. So I'll just look at the names afterwards, which is address, customer address, product category, product description, product model. So these are the kind of tables. And maybe if I expand it a bit more, I'll get column names. So these are the kind of column names. And this PK, as you see, is primary key. So address ID is unique and it does not have any null values. So that is address ID. But yeah, this is how the tables are. This is a sample database. I did not create this database. I just imported it. So happy to share a link across afterwards, but you can just Google AdventureWorks and you will find a link. It is a very well-known database for people to practice. Now what we will do is let's select the product table and let's see what do we have within it. So what I want to do is I want to select all columns. So for that I'll write star, that means all. From where, which table? I want to go to this sales product table. So I'll just write SAL sales dot product. Then the semicolon, when you write a semicolon, that means this query has ended, because you can even continue in the next line. It will only understand where this semicolon is. So yeah, when I execute it, this is the table that I have. So quite a big table over here. But let's say if I do not want all the columns and I want, let's say, name and maybe product number out of this. So what I can do is instead of a star, I can write name and then I can write product number. Right. So all I've done is instead of a star, I've just changed it to column names and I execute this. So I get name column and product number column. Right. Okay. Now, what else can I do over here? Maybe I add one more column so as to have more operations to deal with. So I'll just add color and maybe size. You can look at the names. So we have color column, we have a size column. So let's look at these columns out of this product. So then again executing this. So I have color, black, and size this. Okay. Now what if I want all those products which are black and color? So then I can use where clause. So basically, at a minimum, for fetching or for getting data from a table, you would need a select clause and a from clause, right? Because select will tell you what kind of column do you need, and from will tell you which table. Now, with these two commands, you are fetching all the data that you can, right? Now, if you want to prune or you want to filter across the data, then you use more clauses because you want to get to the data which you are interested in. So for that, what you'll use a where clause. So, SQL, if you read it out, you can understand the commands just by reading it. So like select name, color, size, product number from product table where maybe color, because color is a column, right? Color is equal to black. Okay. So yeah, I can filter and I get the color black over here. So I get all the products which has the color black. Right. Okay. So this query worked. Now, I think let me just roll back and remove this where part. Let me see if I have any null columns or null values in this color column. So when I execute this, do I have any null values? Yes, I do have any null, like some null values in this column. So let's just close this column by understanding one more item out of it, which is where color is not null. So when I write this, that means I can filter across on those values, which at least has one value for the color column. So we want all the rows which has some value for the color column. And if it does not have any value for the color column, I do not want those rows. So ideally, I wouldn't have anything from 98 to 109. This query works. So when I execute this, see, now if I scroll down, I do not have any null values. It's concentrated on this column. I do not have any null values in the color column. Of course, I have it for size because that was my goal. My goal was to not have any null values for the color column. So I am able to do that just by changing this part of the query. Now, sometimes I want to filter across. Let's say you have this product number, right? Do you recognize some aspects around the product number, which is FR? Then I have BK. So maybe there is some relation with FR. Maybe it has to do with product coming from France. I don't know. It could be something, right? But I'm only interested in those products which has this FR starting from the FR. So this is a kind of a more complex kind of a query, but not too complex, but we need one more thing to understand, because whatever we have been doing so far, currently when you do this, you're specifying the exact value. Now you're looking at a subset of the string, right? Which is a string which has fr. I want only those values out of the product column. So for that, you would need to use something called as a wildcard. So okay, first of all, let me write down things which we already know, which is I want to filter across this product number column, right? So I'll write where product number, and then I'll write something which would just filter it. But I know product number is a start. Now product number, after that, I'll use a wildcard, but before that, I need to use this like. So when I write like, I can use what we call as wildcard. So we have two sort of wildcard, which is an underscore and this sign, percentage sign. Now, I do not want to go into the regex part of it, but think of this as a placeholder for a single character. So anything could come over here. And when you write a percentage, wherever this is written, there could be anything that would come after that. And so let me just write this. And just to see that this output that you see, when I wrote just this percentage sign, wouldn't change at all. So this output wouldn't change at all, even though I have made some changes to this query, right? So I'll just execute this. As you can see, the output didn't change at all. Why is it so? Because this percentage sign is saying that like percentage means it could be anything. But of course, I want to filter down, right? So what I want is that I want the string to start from fr. After that, because see, all the strings that are starting from fr has fr, then hyphen, and then all the odd digits, which I'm not interested in. I'm just interested in fr and then hyphen. So what I do is I write fr, I write a hyphen, and then what I'm not interested in, I'll replace that with the percentage. Now execute this, see what you get. So with this query, I can filter across product number, where product number is like fr hyphen, and then it could be anything because we wrote a percentage sign. Percentage sign is a placeholder for anything. Right. But of course, we'll go more into the like operator. But let me say that what if I have to sort this. So I have this output. Okay. Now I want to sort the output with size. So I want to sort this with respect to size, but in descending order. What I can do is understand this semicolon will only come after the query is ended. So after where I want to order the data. So I'll use order by, right? And then I want to order by size column. So I write size. And then how do I want to order? I want it in descending order. So I write DESC. Now I'll just remove this and execute. So yeah, now I have this output, but with size starting from the highest value to the lowest value. Now, what if I just want only top, let's say 5 or 6 rows out of this? Then what I can do is I just have to write top and specify the number of rows, 5. That's it. So I'll only get 5 rows. So with this, kind of an example, we covered a lot of things. We started off with product table. Then we, pruned the number of columns that we want. Then we also looked at how we can, filter across a particular color. Then we looked at how we can filter across the column contain starting off with a subset of a string like fr with a like operator. Then we saw how to order the table or order the output by using order by. And once I've ordered, we also saw how to get the top 5 rows. So all of that with just one single example, and that is how lucrative kind of commands SQL have. So you can it's quite easy to manipulate the commands once you have a greater understanding, and once this becomes intrinsic, so then you can just write the commands very easily. Now, all right, now we'll look at one last part, after which I'll have to apply to call, but that will let's look at some more commands on aggregation. But before that, let's come to a point where we need where we actually need aggregation to do. So let's start with select star from sale t dot product. Execute. All right. So I have this list price, and I have what size and or maybe I want to get a a count of like how many total products are there. I'm not gonna count these rows. Maybe this is extending, but how many rows are there over here? So I want to count how many rows are there in this output, right? So for that, I do not want all the columns. What I want is the count of all the columns. So when I write count, it'll make more sense when I execute this. So when I write count, what it will do is the output will be replaced by just number of rows that this table has. So when I write count and I execute this, I get this as an output. Now you can see like there is no name given to this. So what I can do is I can rename as well. But for that, I will need to use as. So for count asterisk as, then I'll have to mention this, which is the column name that I want to give this. So it will be number of rows. And this is just in SQL Server that you have to supply the name in this square brackets. In MySQL, it is in a different way. So let's move, execute. So now I have changed the name of the column. All right. Can I do something else? Maybe let's think of something else. So what if I have select star from, and I want to go to the table sales LP dot product. Now I only want to get all those product which has the color black. So where black. So let's see first, what do I get? Okay. So I'm getting all the products with color black. What I can do is, what if I want the average price or average of the list price? Okay. This is the list price of that particular product. I always want to see what is the average list price of product, of black color. Then maybe there is some relation to it. Then I might check with red color and then see if the average price is changing. So what I want to do is, instead of this column, I'm only interested in what I'm interested in list price. So I'll just write list price first. So list price, right? Okay. Now execute and see. All right, I'm having list price. Now what if I do not want this list price, but I want average of it, right? So what I would want to do is I can use an aggregate function. So that function will be responsible for taking all the values and taking an average of the values. So this function is called as an average function. So average, I write the column from product table where color is black. Now, sorry, execute. So yeah, I have the average price of the product colored black is 757, but again, I do not have a name for it. So I can write as, and the name would come over here. Then I execute. So yeah, I have a more suggestive column name and a value. But maybe I also want to know how many black products do I have in my itinerary. So that means I want one more column and I want one more function. So one function is doing the average of the list price, and one function is counting the number of rows in the list price. So what I can do is I can write one column is this entire thing is I'm talking about a single column. After that, I'm talking about another column, but this time I want to count. What do I want to count? I want to count number of rows in list price. Now, but what do I want to call this column as? So as number of products. And again, square brackets. Execute. Awesome. So I have average price of black product as 757 and number of products that I have is 89. Now, if I want to check for the same thing for a product color red, all I need to do is red. Done. So these are the number of products in red color and the average price of it. All right. So maybe I'll show maybe two more kind of columns, and then we can end the session over here. So we have average count, and then we have more, which is maybe max, which is the max price. I also want to know the max price. So max, and then the list price. Now I'm not naming that column for now. And main. Then I have list price. Awesome. Execute it all. Okay, so maximum price of a product. Again, it is a red product. So let me make it black so that the column name and the query matches. Right. So black product is this. Number of products is 89. Maximum list price is 3374, and the cheapest one was for 24.49.